Is Soumya Agarwal 2207-836 and I am going to explain the first lab of Big Data Security Lab, that is a secure file transfer system using a symmetric key encryption. So the problem statement states that we have to design and implement a secure file transfer system using AES 256 encryption in CBC mode, and the system should consist of a sender application that encrypts files, a receiver application that decrypts file, a secure key exchange mechanism using RSA or ECDH, but in this assignment I am using RSA. And then the authentication is to prevent unauthorized decryption and integrity verification using HMAC. So let's jump on to the code. So in the part 1 you can see that we have created a key vault module. So its purpose is to secure storage of AES keys at rest. The key vault module is responsible for securely storing cryptographic keys on disk. Since human passwords are weak and not suitable for direct encryption, the password is first converted into a strong cryptographic key using PBKDFT F2 with SHA 256. You can see here that we have used that key. Yeah, this key PBKDF2HMAC, and the encrypted AES key and its associated salt are stored inside a JSON file called the key vault. As a result, even if an attacker gains access to the vault file, the AES key cannot be recovered without the correct password. So the key points are the that the PBKDF2 slows down proof attacks and the salt prevents rainbow table attacks. So let's move on to the second part, that is the standard key management. This section handles generation for the system. First, an RSA 2048 public private key pair is generated for the receiver. The public key is shared with the sender while the private key is kept secret. Second, a 256-bit AES key is generated using a cryptographically secure random number generator. This AES key acts as a session key and is used to encrypt the document. RSA is not used for file encryption because it is computationally expensive. Instead, it is only used to protect the AES key. Now, our third stage is the encryption process. The encryption process uses AES 256 in CBC mode, a random initialization vector 4, which is called as, is generated for each encryption to ensure that encrypting the same file multiple times produces different ciphertext. Since AES operates on fixed size blocks, PKC S7 padding is applied to the plain text. After encryption, HMAC SHA-256 is computed over the 4 and ciphertext to guarantee data integrity and authenticity. Finally, the encrypted file is stored in the format 4 plus ciphertext plus HMAC. So the security properties that are achieved in this is the confidentiality using AES 256, integrity and authenticity using HMAC SHA 256, and randomness and replay protection using 4. Now let's move on to the decryption process. So the purpose of it is to secure decryption with tamper detection. During decryption, the encrypted file is first parsed to extract the 4 ciphertext and HMAC. Before attempting decryption, the HMAC is verified to ensure that the file has not been modified. If the integrity check fails, decryption is immediately stopped. If the HMAC is valid, AES 256 CBC decryption is performed using the recovered AES key, and PKC S7 padding is removed to restore the original document. Important highlights of this text is that HMAC verification is performed before decryption to prevent tampering and cryptographic attacks. Yeah, so you can see here. Now let's move on to the part 5. The part 5 of our code is that this part implements the hybrid encryption concept. The sender encrypts the AES session key using the receiver's RSA public key with OAEP padding. You can see here that I have applied the OAEP padding, and then the encrypted AES key is sent to the receiver. On the receiver side, the AES key is decrypted using the RSA private key, ensuring that only the intended receiver can access it. So you can so for the part 5 you can say the one line summary would be the public key encrypts and the private key decrypts, which is the main you can say the building block or the stone of this assignment. So now let's see the output of this. Yeah, so let me, yeah, so you can see that so you can see that a sample PDF file is first created for demonstration purpose, like the one with document underscore 2201 AI36, which is by roll number. The receiver generates an RSA key pair and shares the public key with the sender. The sender key then generates a random AES-256 key and securely stores it in the key vault using a password. Next, the document is encrypted using the AES key. The AES key is then encrypted with the receiver's public RSA key and transmitted securely. On the receiver side, the AES key is recovered using a private RSA key and the encrypted document is decrypted. Finally, the decrypted file is compared with the original file to verify correctness. So in this you can see that this is my document which will be encrypted, and this is the encrypted version of the document, and this is the decrypted version of document, and this is the key vault where we have added the salt, and you can see here the receiver's public key which is available to all.